Hello and welcome to this course in Business Analytics using Excel. I'm Rajesh Durbala, your instructor, and I've been an assistant professor in Business Analytics for the past few years. I've been teaching in various universities and different institutions. I conduct workshops on analytics using Excel. So, what's there in today's lecture? Let's move ahead. Today we are going to learn analytics on spreadsheets. We learn how to create some models using the Excel spreadsheet. So after this video you will be able to learn the good spreadsheet model building principles. We use certain principles which help us to create awesome and wonderful spreadsheets. Okay, now that's one of the most important thing. We'll be learning some basic principles on model building using spreadsheets. Now you have to understand that we'll be using the same principles throughout the course. So whenever we are using a spreadsheet, there are some do's and don'ts which we have to abide by. So I'll be guiding you through those do's and don'ts. And the second objective is we'll be able to write correct formulas in an Excel worksheet. And the third objective would be copy formulas from one cell to another or to a range of cells. Okay, copying data is not the same as copying a formula. So when you're copying a formula, you have to take certain precautions, and through this we are going to learn what are the various precautions and what are the various things you need to keep in mind while copying formulas. Okay, moving ahead, let's do a problem and see how things work. So first of all, we learn the good spreadsheet model building general principles. Okay, so the first one, that's the Excel's golden rule. If formula input, that is the parameter, assumption or variable, can change, but it in a cell, we put it in a cell and refer to it in the formula with a reference cell. What do you mean by this? Let me explain. See, whenever I create a formula, we should not be typing values into it. We need to refer the values. That is to say, I keep my spreadsheet very organized. I keep an area where I have the parameters, an area for assumptions, and an area just for variables. So in the area where I create my formulas, I do not type the values for any of the variables. What I simply do is I refer the variables, the value of the variables, from the area where I had just kept for the input values. Okay, once we start doing it, you will have a better understanding. So the second one is label all formulas. Okay, it is very important to label the areas, because I'm not making the spreadsheet for a one-time use or for a one-time purpose. What we are trying to do is we are creating a tool, and whenever I use or I am in need of such a requirement, I can pull out this Excel sheet and use it for my requirement. So it is very important that I remember what is put in the different cells. Okay, so for that, labeling is very important. So third one, separate the formula area from the model area. As I told you while discussing the first point itself, you need to segregate your spreadsheet into various areas. One is for your input area, for one for variables, one for parameters, one assumptions, whichever. There's no such hard and fast rule that you have to be doing it the way I do it, but the basic purpose or what I wish to communicate is you need to create separate areas for different things. Okay, you can't mix everything together and put it at the same place. Then model is where you create your formulas and where you can put your decision variables. Okay, so model area is where you get your output. You create your formulas by referring input values from the different areas. Okay, then label all elements in the model area. That's again very obvious. Use appropriate number and stylistic formatting to make the spreadsheet easy to understand. Remember, number formatting is a facade. So again, the same thing, it has to be aesthetically or visually appealing. That's the only point. Okay, you have to keep the formatting and everything very clear so that it becomes aesthetically appealing. Okay, next, keep default alignments to visually portray the data type. Numbers to the right and text to the left. This is the default setting. Okay, the moment you start changing the alignments, Excel can start misbehaving, so mind it, you do not mess up with the default alignments. Name all sheets and files smartly. Okay, many a times we have the habit of writing my sheet, my Excel sheet. No, don't do that. Okay, so name the sheets. Like if I'm using or creating a sheet which is only for profit calculations, okay, so I'll name it as a profit calculator maybe. Okay, if one sheet I'm creating just for break-even analysis, I'll just write it as break-even analysis. Okay, so the moment you look at the sheet, you should be in a position to figure out what the sheet is going to do, or what the how the sheet is going to help you. Then sometimes it's helpful to create math formulas or an influence diagram to describe your model. So whenever you are creating a model, it's always better to write down the basic formulas that you are using, so that it's easier for even other people who wish to use your sheet. Okay, so let's move ahead. Now let's solve a simple problem and see how this works. Okay, let me take you through the basic problem. This is your problem. You can pause this video and you can take notes if you require. So this is what I call a boomerang problem, and the learning outcomes for this is to create models and model building. Yeah, the spelling of model is incorrect. That's not a problem. Okay, now let's see. The Boomerang company, Gel Boomerang, makes boomerangs, obvious. Okay, the 4-armed freestyle boomerang quad has a fixed cost of $17,430 and has the following variable costs. Material cost per unit is $4.3. Assigned indirect costs is $1.15. Labor cost per unit is $4.17. In addition, the wholesale price, the revenue that is charged for each, is $16.5, and it is assumed that the percentage of boomerangs made that are defective cannot be sold is 2%. Okay, so 2% of the boomerangs are defective and cannot be sold. So what is the implication? That is to say, if I produce 100 boomerangs, 2 would be defective, only 98 could be sold. Okay, so simple, my revenue gets depleted by 2%. That's the implication, nothing serious about it. The goal is to calculate profit. Now create a model that will calculate total profit if the number of units is 2000. Now okay, so number of units sold is 2000, so what would be the total profit? Then create a model with math formulas. Fine, that can be easy. Use goal-seek to calculate the break-even point by changing the formula input units. So I have to use goal-seek. Okay, this is a very interesting tool which you have to understand, and we will be using it also. So the tool that we are going to use is goal-seek. Okay, then use goal-seek to calculate break-even point by changing the formula input revenue. Fine. Okay, then create a formula to calculate the break-even points at unit sold equals 2000. So this is my problem. Yeah, so shall we solve it? Okay, now I'll take my Excel. Yeah, this is the Excel sheet. Just to save time, I have already punched in the values that are there in the problem, so you can create your own Excel sheet. Now just see how I have segregated my sheet. Now this sheet, these are the input parameters, assumptions or variables that are provided to me. Okay, so this area, it gives me the entire values, the input variables that are provided to me. Okay, gel boomerang, it's manufacturing boomerangs. Okay, products to be made is quad. This is the basic information. And now see, I'm just abbreviating all the terms. Like fixed cost, I'll be using FC. That will help me create mathematical formulas. Okay, fixed cost FC, the value. Okay, material cost per unit, MC, that's again the value. Assigned indirect cost per unit, IC, that's again value. Labor cost, LC, again the value. Revenue R, that is again the value. I have my percentage of boomerangs that are made and cannot be sold, D, that's again the value. Now my goal is to calculate total profit. Units sold is 2000. Now I'm creating my math formulas. Okay, now I have written down all the formulas so that it helps me or anyone else who uses the sheet. That would be quite interesting and insightful for that person as well. Okay, now let's see. Variable cost per unit equals to VC. Okay, that's equals to, I have, what are the variable cost elements? Okay, I have the material cost, I have the labor cost and the indirect costs. Okay, so when I sum them up, that is material cost plus indirect cost plus labor cost, I get variable costs. Now total variable cost, now you can understand, see these costs that are provided to me, material cost and indirect cost and labor cost, these are costs per unit. Okay, so if I have to get the total variable cost for almost 2000 units that are 2000 units that are being sold, okay, I need to multiply the variable cost per unit with 2000. Okay, 2000 is the units. Okay, this is not the value, so I have to remove the dollar. How do I remove the dollar? That is, click on the cell, go to right click, and then I go to format cell and let the box open up. Okay, you get this kind of a box. I just click on the number. So once I click on the number, it will just be the value. Okay, so if you are not very comfortable with the decimals, you can remove the decimals also. You will follow the same process. I go to format, you can remove the decimal places. Okay, now you can see I have removed the decimal places, so the units sold 2000. That's simple, straightforward. Okay, so total variable cost, that would be variable cost per unit multiplied by the quantity, that is 2000. Okay, and then total cost. Total cost, what would be the total cost? Total cost would be fixed cost plus the total variable cost. That's fine. Okay, so fixed cost is given to me as 17,430. Okay, plus the total variable cost that I calculated in the previous step. Total revenue, the total revenue would be revenue per unit. Okay, what is the revenue per unit? That is 16.50 multiplied by quantity, that is 2000. But will I get money for all the 2000? No, because 2% are defective and cannot be sold. So I'll reduce this quantity by 2%. Okay, so what I do, quantity 2000 into 1 minus the defect rate. The defect rate is 2%, so 1 minus 0.002. Okay, that would not 0.002, it would be 0.02. Okay, that would help. So total profit would be total revenue minus total costs. Unit break even, so this is the formula for break even, that's as per the requirement. Fixed costs divided by the revenue minus variable cost. This is what we call the contribution. Okay, so I have plugged in the math formulas as well. Now this is my model building area. Okay, this is the area where I will create my model. Okay, so let's see, I'll calculate each and everything. Now let's see the first one, that is I have to check what the variable cost per unit would be. That is the sum of material cost, indirect cost, and labor cost. Okay. Now, how will I do it? Just see. Okay. This is the area where I'm creating or finding my total variable cost per unit. Okay. So let me plug in the formula. To start with the formula, I select the cell, put equals to. Okay. What is my golden rule? I should not type values. I should be referring values. Okay. Now just I scroll up. I just see material cost per unit. This is my material cost per unit. Okay. Then I need to put my plus sign. Then indirect cost. I'm just referring the cells. Okay. This is very important to refer the cells. You shouldn't be typing any values. Okay. I have referred this material cost, indirect cost, and labor cost per unit. Okay. Now I hit enter. Now this is the value. Okay. I get $9.97 as the total variable costs. Now let me find the total variable costs. Okay. What will be the total variable costs? That is equals to the previous cell, that is variable costs per unit, multiplied by the total quantity, okay, the total units sold. So I can refer this cell and I hit enter, I get it. Okay. Now simple. Okay. Now let's see. I want to find the total cost. My total cost would be equals to this cell. If I see the formula, that is fixed cost plus total variable cost. So I have taken the total variable cost. Now I have to go for the total fixed cost. Okay. Now where is the total fixed cost? Okay. Now I get my total fixed cost. When I hit enter, I get 19,944.30. Okay. Do you sense something is wrong? I can see that my total variable cost is 19,940 and I am getting a weird value. Okay. So let me check my formula. So I see I have this equals to B26, that's fine, plus B5. What is B5? I think I've taken something wrong. It should have been B4. Can you see this? I should have taken this cell rather than B5. Let us check it. I remove this, I select this, hit enter. Simple. Okay. So the mistake that was committed, now it's rectified. Now I have total revenue. How do I calculate my total revenue? Okay, this is a bit of complex. Just pay attention. Equals to, I scroll up to check what my revenue is. Okay, this is my revenue. Then I have to multiply it with the quantity. So I do it. Okay, I have multiplied it with the quantity. Then I have to again multiply it with 1 minus the defect rate, that is 2%. Okay, right. I do it. Now let's see what's going to happen. So this is my total revenue. Okay. Now let us see what my total profit or loss would be. I know my total profit would be total revenue minus my total costs. Okay. So you can see I am incurring a loss of $5,030. So that's a huge loss. Now I have to find the break-even point. How do I get my break-even point? Now here I'm going to teach you a very interesting and important tool in Excel. The tool is called Goal Seek. How do I reach that tool? Okay, there's a shortcut. Go to Alt T G. Then you can see a box opens like this. So what was the tool? That was Alt T G. Okay, now how do I go ahead with this? Now set cell, which is the cell that I have to set. Now understand, the break-even point means a point where there is no profit, no loss. Now which cell I need to set? This is the cell which talks about profit or loss. So I have to set this cell. Okay, to what value? The value that I need to set, if I need to find the break-even point, there shouldn't be any profit or loss. So the value should come to 0. Okay, by changing which cell. Now let us say I'm working on quantity. So which cell should I change? Now let us say if I'm working on this, the units sold. Now how many units I need to sell in order to achieve this break even? Okay, so this is the cell. I hit enter. I say, just see the magic happening. Okay, I say okay. You can see my units break even should be 2811. Okay, so the number of units I have to sell in order to achieve my break even point would be 2811. Clear? Was that interesting? Yeah. Okay, so what did we learn? We learned how to create basic mathematical formulas. We learned how to create profit modeling, and we have also learned how to find the break-even point using the goal seek. Okay, now you can see the moment I'm producing 2811.29, or put it this way, when I'm producing 2812 units, I am reaching my break-even point. That is a point where I am not able to make any profit or loss. Okay, any production or any sales beyond this point of 2812 that can get me a profit. Okay, now again I'll format this and convert it into values. Go to format cell. I go to number, remove the decimal places, say okay. This is exactly 2811, right? Right. Okay, so what's next? So in the next video I'll be teaching you how to go for absolute and relative referencing and what is its use. Okay, you can get in touch with me on LinkedIn, Facebook and Twitter. You can directly mail me as well at rajeshdorbala@gmail.com. Till then, thank you for your attention.